So from the 1993 E&M multiple choice test, I'd like to work number 45, 46, and 47. Okay, and here's what we've got. We've got this circuit right here. We've got a 12-volt cell here. I've got a 6-volt cell, but pointed the other way. I've got these resistors. Here's an unknown resistor. And I've got, it says, the current in the circuit is 2 amps. And I think you can tell that that current, because this is 12 trying to push it this way, and this is 6 trying to push it the other, that the current is going to go in this direction. Okay? So it wants to know what is the resistance R. And the way I would solve it is go on a voltage walk. You know, let voltage man take you by the hand and go for a little walk around the circuit. And it doesn't matter where you start, but let's start at X and go around like this. So if I'm going to start here and I'm going to go like this, I get to this 6-volt source, but I'm stepping down in voltage. So this is going to, well, so this is for number 45. I'm going to go minus 6 volts, and then I get to here. Now I'm going with the current. The current is going like this. I'm going with the current, so it's going to be a voltage drop, and it's going to be 0.2 ohms times 2 amps. And remember, an ohm is a volt per amp. So that's going to be, well, 0.2 times 2 is 0.4 volts. And then I get to minus R times I, which is 2 amps. And I'm going to go off screen here in a second. And then I get here and I go minus 1.5 ohms times 2 amps. And then if you look right here, the we have minus, I guess I could have made my life easier just adding these resistors together. That would have been a lot faster. So, but I didn't think to do that, so I'm just going to follow through with what I'm doing. This is minus 0.3 ohms times 2 amps. And then I get to this plus 12. Okay, I get to this guy plus 12, and now I'm back where I started. And if I'm back where I started, it has to be equal to 0. Now again, this is multiple choice. Thank you. This is multiple choice, right? So I'm just gonna, I would do, you know, this. You can almost do this in your head. So minus 6 times, or plus 12 is 6, and then I'll put it the other side. So this is going to be equal to negative 6 volts. And then here, this is 0.4. What is this? This is 3. And this is 0.6 volts. And so, and these are all negative, right? So negative 0.4 plus negative 0.6 is 1, plus negative 3 is 4. So that's negative 4, and then I'm going to add it to the other side. So I get plus 4 volts. And, and that's going to be equal to negative R times 2A. And let's see, negative 6 plus 4 is negative 2 volts. And, well, I divide that by 2 amps. And that'll give me a resistance of, oh, and the negatives cancel too. So R is equal to 1 ohm. So for 45, the answer should be A. Is that right? I think I did that right. All right. Now, okay, I'm videoing this. I'm trying to explain it clearly, but you should be able to do this a lot faster than how I'm explaining it. Okay. If it takes this long for you to do a problem, you're not, well, you got to go fast. Okay, so now let's do 46. And what does 46 say? It says the potential difference between points X and Y. So now I'm just going to go on a voltage walk between X and Y. So, and it doesn't matter which direction you go. So I'm just going to go like I did before. I'm going to walk from here, 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 and then now that I know what R is, I'm going to go to that. So I'm going to go 6, or actually, I'll tell you what, I don't want to use this value because what if I made a mistake? I don't want to carry that mistake forward. So let's go this way. So I'm going to go like this. So it's going to be minus 12 volts. Now I'm going with the current now. So, I mean, I'm going against the current. So this is going to be a voltage gain here and here. So let's just add these two resistors together. I got 0.3 and 1.5. So that's going to be 1.8 ohms. And I know the current is 2 amps. And so I should be done here because I'm now at location Y. So this is negative 12 volts. And what is 2 times 1.8? So that should be 3.6. And so when I add these together, well, what's 12 minus 3.6? Well, what's 12 minus 3 is 9, minus 0.6 is 8.4. And there's my answer right there. So the answer is C, 8.4. And the potential difference between point, I went from here to here, so I would get negative, but, here to here I get, so I mean, it's fine. The sign doesn't really matter. All right. And then let's do number 47. How much energy is dissipated by the 1.5 ohm resistor in 60 seconds? Well, you have to use the, well, you know what, oh, okay. So power equals I squared R. And you want to use the given values. You could use, if you know the voltage drop, you could use I times V, but you're depending on knowing what happened in the rest of the circuit from previous problems. So I'm just going to use I squared R. So that's going to be 2 amps squared times R, which is 1.5. So the power, 1.5 amps. I'm sorry, ohms. And so this is 4 times 1.5, which is 6. So that's 6 watts. But that equals the energy dissipated. I'll just use E for energy here, over time. So I want to solve for, I know what time it was. So this is going to be 6, well, a watt is a joule per second. And the time was given to be 60 seconds. So now that will cancel. The seconds will cancel. And 6 times 60 is 360 joules. And so, again, the answer is C. So, big picture-wise, what do you need to know? You need to know how to go on a voltage walk. Oh, I'm off screen. You need to know how to go on a voltage walk. That if you're going, what direction you're going. If you're going like this, it's a voltage gain. If you're going like this, it's a voltage drop. For resistors, you need to know when is it a voltage gain and when is it a voltage drop. If you're going, if the current's going this way. Now you may have done this on another problem, but you need to understand how to do these things with, well, basically with with electric cells, with resistors, also with capacitors and inductors, you need to know how to step up or step down in voltage as you're going on a voltage walk. And you need to know Ohm's law. Delta V for a resistor is equal to I times R. And of course you need to know power equals I squared R, and that power equals work or energy over time. And so those are the big ideas. These are the things you need to have memorized. Hey, if you know this and you know this, you can combine these two to easily derive the other two power equations for circuits. All right, so that's 45, 46, and 47 from the test. I hope that was sort of clear. That is all.